Everything you believe about Jupiter is wrong. It is not a gas giant. It never was. NASA found something so absurd inside it that this planet becomes the most dangerous and most enigmatic object in the entire solar system. Imagine a world where the laws of physics simply break, and that is only the beginning. If Jupiter really is what these new pieces of evidence suggest, then we are facing the biggest scientific plot twist of our generation. Jupiter has always seemed too simple to be true, like that quiet neighbor who hides something enormous behind the door. It is so colossal that more than 1,000 Earths could fit inside. And if our planet were a grape, Jupiter would be a basketball. The strange part is that even with this ridiculous scale, it keeps escaping any easy definition. The harder science tries to fit it into a category, the more it looks like a liquid planet disguised as an ancient myth. When the first images from Pioneer 11 and later Voyager 1 arrived, everyone thought the mystery would finally be solved. The effect was the opposite. The more vivid the clouds were, the bigger the enigma became. It felt like staring at a living wall, where even the famous Great Red Spot looked like a small detail in an impossible puzzle. Beautiful, yes, but it explained absolutely nothing. And that frustration opened the door for something much bigger to be revealed. Researchers eventually realized the problem was not the lack of data, but the nature of the giant itself. Jupiter's gravity is so intense that it bends human logic, and its behavior escapes any simple model. Trying to describe it is like trying to explain the ocean by looking only at the foam on its surface. Beneath that turbulent veil were signs of deeper structures that intrigued even the most seasoned scientists. And one of those clues would come from a rare and devastating event. The Shoemaker-Levy 9 comet appeared like a cosmic warning, the kind that makes anyone reconsider their own insignificance in the universe. It had been torn into dozens of fragments and was about to collide with Jupiter, something researchers say happens only once every 6,000 years. Tension among astronomers was almost physical because no one knew how that encounter would unfold. To make matters worse, the collision would occur on the far side of the planet, completely out of view from Earth. But then came the kind of impossible coincidence that feels written by space itself. The Galileo probe, sent to study the giant, arrived at precisely the moment of impact, as if the universe had timed its entrance perfectly. Each fragment hit the planet with the energy of 300 million atomic bombs, leaving dark scars that stained the clouds for months. These marks revealed details no Earth-based telescope could ever capture. The impact transformed planetary science in a way nobody expected. For the first time, it was possible to observe how a giant reacts under pressures so extreme that everything changes within seconds. And while Galileo recorded every explosion, it also detected clues that pointed toward something far deeper, as if the planet itself were trying to reveal secrets hidden for ages. Secrets that would only make sense when another mission dared to go even closer. After that historic encounter, the Galileo probe began detecting something no one expected: signs of water in regions where there should only be storms of gas. It was as if Jupiter hid pockets of moisture in the middle of chaos, contradicting decades of scientific certainty. Studies show these signals were not artifacts or errors, but real hints of an environment far more complex than imagined. And all of this set the stage for an even bolder discovery. It was only with the arrival of the Juno mission in 2016 that the puzzle truly began to take shape. The probe flew in extremely close orbits, almost grazing the upper clouds, and sent back data that shattered old myths. That classic image of a gas planet no longer made sense. Measurements showed something solid and radically different. It was as if the entire planet were covered by a thin skin of turbulence, hiding an unexpected world beneath. The first major twist came when scientists realized Jupiter was not made of gas at its core. The visible layer was just a fragile varnish over a deep, fluid colossus. Researchers discovered that beneath the clouds, there's an environment so dense it behaves like a vast hydrogen ocean, capable of swallowing any simple model. And this revelation opened a doorway to even more extreme secrets, paving the path for a descent that borders the impossible. Jupiter's cloud layer looks soft from afar, but inside the story is completely different. Researchers describe a world with temperatures of -100 degrees Fahrenheit, where ice crystals and ammonia collide like floating blades in chaos. Each impact releases massive electrical discharges capable of lighting huge regions of the planet for several seconds. It is a brutal spectacle that challenges any simple idea of a failed star asleep in space. Meanwhile, giant turbulent masses rise and collapse like living mountains, generating lightning larger than entire continents. In this insane environment, the famous Great Red Spot gains a new meaning, revealing itself as far deeper and more violent than any image has shown. Studies indicate this storm has enough energy to reshape winds that travel thousands of miles, and this is only the surface of the problem. The strange part is that these colossal storms exist within a layer only a few dozen miles thick, a delicate shell hiding something much larger below. The more scientists analyze these phenomena, the more they realize they are dealing with forces that do not match any known planetary pattern. Each lightning strike seems to announce an even more extreme depth, as if Jupiter were preparing the stage to reveal the secrets surrounding its diluted core. As the imaginary descent begins, Jupiter's outer layer dissolves like wet paper. The pressure rises so fast that any human structure would be crushed in seconds. Heat intensifies as if the planet itself breathed fire. A few thousand miles down, hydrogen stops behaving like a gas and begins forming a dense, hot ocean. It is the beginning of the transformation that eventually creates metallic hydrogen, a substance scientists desperately try to reproduce in labs. As you sink into this insane environment, everything defies Earth logic. Liquid hydrogen accumulates in layers so deep they force anyone to rethink the meaning of the word abyss. Researchers believe this region may stretch for almost 20,000 miles, forming the largest ocean in the solar system, an ocean made of pure compression and energy. It is so vast that it makes our seas look like puddles. And this immensity connects indirectly to the Shoemaker-Levy 9 impact, which revealed how the atmosphere reacts long before reaching the interior. The deeper the journey goes, the more the planet reveals its true nature. At extreme depths, where pressure is millions of times greater than on Earth, hydrogen not only flows, it conducts electricity, vibrates like hot metal, and creates violent currents. It is a region where even physics seems to lose patience and write its own rules. And this chaotic environment prepares the stage for the most surprising phase of all, where the impossible becomes normal, and matter reaches a state almost unimaginable. Reaching the metallic hydrogen region feels like entering an alien laboratory. Matter behaves so strangely that scientists still debate basic details of how it works. Heat reaches levels capable of vaporizing any terrestrial metal. But there, paradoxically, hydrogen flows like liquid and shines under extreme pressure. In this place, the planet reveals its most radical essence, where a massive sea of metallic hydrogen stretches for tens of thousands of miles. At this depth, everything vibrates as if the planet had an electrical heart. The density is so extreme that hydrogen gains metallic properties, conducting electricity with efficiency that intimidates even experienced physicists. This metallic ocean moves in giant currents, twisting and circling like rivers of liquid light. These colossal motions create a magnetic field so intense it surpasses the strength of any hydrogen ocean ever imagined. The most fascinating part is how these deep currents shape the entire identity of the planet. Jupiter's magnetic field extends millions of miles into space, forming a protective bubble that would crush any careless spacecraft. Researchers indicate this colossal structure is the direct result of the furious dance of metallic hydrogen inside. But behind this electrical spectacle lies a disturbing mystery. What exactly is hidden beneath everything we call Jupiter's core? For decades, books and models confidently claimed that Jupiter had a solid core the size of Earth buried at its center. It was a comforting idea, almost intuitive, like imagining a hard heart supporting the giant around it. But as new measurements appeared, that image began to collapse. The Juno mission revealed the interior of the planet does not behave like a defined block, but like something far more fluid and chaotic. Recent studies suggest this core is diffuse, as if rock, metal, and liquid were mixed in a huge region without clear boundaries. This area may occupy half the planet's radius, completely dissolving the idea of a rigid, centralized structure. The liquid planet concept has never made more sense than here, where the internal mixture ignores everything Earth-based physics teaches. And the more scientists try to simulate this scenario, the more questions appear. The most dramatic theory suggests that a giant planet, possibly 10 times more massive than Earth, collided with Jupiter in the distant past. This would have destroyed the original core and scattered material throughout the interior. The problem is that simulations indicate everything should have resolidified over time, but it did not. This paradox keeps Jupiter wrapped in mystery and opens the door to a debate that touches the very identity of the giant. Is it a planet or almost a failed star? The formation of Jupiter has always split astronomers, as if the planet carried two competing identities. One theory says it began small, like any rocky world, gradually accumulating material until becoming the colossus we see today. The other claims everything started with the collapse of a massive cloud, almost large enough to ignite like a star. This doubt hangs over every layer of Jupiter and makes many experts see it as a liquid planet on a cosmic scale. When we look at its composition, the similarity to the Sun becomes impossible to ignore. Jupiter has the same basic elements as a star, but did not reach enough mass to ignite nuclear fusion. That is why many call it a failed star, a star that almost awakened but froze at the threshold of creation. The comparison between these two destinies, planet or star, rock or collapse, fuels one of the oldest debates in modern astronomy. The most intriguing detail is that the diffuse core revealed by the Juno mission seems to combine parts of both theories. One part suggests slow growth, another resembles a violent collapse all at once. Researchers believe Jupiter may be a rare mix of processes that fits into no classic category. And if understanding its origin is already complicated, its consequences for life on Earth create an even more personal debate involving protection, risks, and a role almost no one imagines. Jupiter works like a wandering shield traveling through the solar system. Its colossal gravity deflects comets and asteroids that could hit Earth, creating a silent protection most people never notice. Events recorded by researchers show entire trajectories being altered thanks to its presence. Some analyses even reveal that disturbances involving the Great Red Spot influence tiny adjustments in atmospheric currents around the planet. But this guardian role has a dark side that few people know. The same gravitational force that diverts objects can also launch them straight toward us, changing orbits in unpredictable ways. There are records of comets being accelerated by Jupiter like cosmic projectiles. And the Shoemaker-Levy 9Ks showed how brutal an impact can be. This duality between protection and threat makes the planet seem almost mythological in our system. Many researchers also believe Jupiter's early orbit may have migrated billions of years ago, reorganizing everything around it. Some think it pushed dangerous material away. Others argue it may have destroyed entire worlds before Earth even existed. When we consider that influence, understanding the planet's internal structure, including regions linked to metallic hydrogen, becomes even more essential. After all, this behavior shapes not only the past, but the future of life on our small blue dot. Jupiter makes it clear it is not just another planet. It is the key to understanding how entire worlds are born, evolve, and transform. Each new mission uncovers contradictions that challenge everything science considered solid. And that raises an uncomfortable question. If the largest planet in the solar system still hides secrets this deep, what else are we interpreting wrong about the universe? Subscribe to the channel and turn on notifications to keep learning about the most important and unexpected discoveries in our cosmos.